Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at equivalent fractions. So let's start at the number line that we looked at last time. So between 0 and 1 is a whole bunch of fractions. Halfway between them is a half. But I can divide this number line further. Let's divide it into quarters. So if I divide it into quarters, there'll be 4 divisions between 0 and 1. So I have 1 quarter here. This will be 2 quarters, 3 quarters, and then 4 quarters. So when we say equivalent fractions, we're talking about fractions that have the exact same value. So we can see here 2 quarters and a half, they are equivalent fractions. They're both equal to 0.25. Another way of thinking about this, let's say I have some pizza here and I divide it into quarters. Let's say I give you 2 of those quarters. So if I give you 2 quarters, you can have this yellow bit here. You can see that I've given you half the pizza. If I give you 2 quarters of the pizza, you get the same amount as if I give you half of the pizza. Similarly, 4 quarters is the same as 1. If I give you all 4 quarters of a pizza, I've given you 1 whole pizza. So we can say, for example, that half and 2 over 4 are equal. They have the same value. And there are infinitely many other fractions equivalent to a half. We could write 4 over 8. We could write 5 over 10, and so on. All of these fractions are equal. So how do we know if fractions are equivalent, if they have the same value? Well, the idea is if you multiply or divide top and bottom, numerator and denominator, by the same number, you have an equivalent fraction. So for a half, it's the same as 2 over 4 because we've multiplied the top and the bottom by the same number. 1 times 2 is 2, 2 times 2 is 4. What about if we had 2 fractions, let's say 7 over 10 and 17 over 20? Are they equivalent? Well, to go from 10 to 20, we've multiplied by 2, but we haven't done that to the top. 7 times 2 doesn't equal 17. Because we haven't done the same to the bottom and the top, these 2 fractions are not equal. They are not equivalent. In fact, 17 over 20 is more than 7 over 10. If I gave you 17/20ths of a pizza, you would get more pizza than if you got 7/10. So 2 fractions are equivalent. Basically, if you multiply or divide the tops by the same number. What you do to the top, you do to the bottom. Just so you know, you can't add the same number to top and the bottom. So here we could have added 10 and added 10. But that's not what we're talking about equivalent fractions. We're only talking about multiplying and dividing. You have to multiply or divide the top and bottom by the same number, not add the same number to both numerator and denominator. All right, let's look now at simplifying. So simplifying a fraction means to find an equivalent fraction with the lowest possible numerator and denominator. So here we had a whole bunch of equivalent fractions. Of those fractions, this one here, a half, is considered simplest because it has a lower numerator than all the others. It has a lower denominator than all of the others. So we generally want to deal with simplified fractions because they're just much easier to work with. So if you're asked to simplify a fraction, you divide top and bottom, numerator and denominator, by their highest common factor. So let's look at 5 over 15. So I want to find a fraction that's equivalent to 5 over 15, but has a lower numerator and denominator. So how I do that, I divide top and bottom by their highest common factor. Now the highest number that goes into 5 and 15 is 5. So I'm going to divide top by 5. What you do to the top, though, you must do to the bottom. So 5 divided by 5 is 1. 15 divided 5 is 3. See, 5 over 15 and a third are the same fraction. They have the same value. If 5/15 of the class has blue eyes, that's the same as a third of the class having blue eyes. These mean exactly the same thing. This one is simpler because it has a lower numerator and denominator. So we got it by doing the same to the top and the bottom. So let's look at 32 over 48. That's not simplified. How do I know it's not simplified? Because 32 and 48 have a common factor. Now you need to divide top and bottom by their highest common factor. If you don't know what the highest common factor is, you can just simplify in steps. So it turns out the highest common factor of 32 and 48 is 16. Now, if you didn't know that, you might say, okay, well, I know 32 and 48 are divisible by 4. So 32 divided 4 is 8, and 48 divided 4 is 12. So we've done the same to the top and the bottom. But 8 over 12 can still be simplified. I know it's not simplified because 8 and 12 have a common factor. They also have a common factor of 4. So here we're just simplifying in steps. So 8 divided by 4 is 2, 12 divided by 4 is 3. Each of these three fractions is equivalent, but 2/3 is considered simpler because it has a lower numerator and denominator. So 2 over 3 cannot be simplified any further because 2 and 3 have no common factor other than 1. So sometimes fractions can't be simplified. 27 over 63, though, can be simplified because the top and the bottom have a common factor of 9. 9 goes into both of them. So 27 divided 9 is 3, 63 divided 9 is 7. These two fractions are equivalent because I did the same to the top and the bottom, but this one's considered simpler because it has a lower numerator and denominator. All right, let's now look at applying this to a worded problem. So out of 200 Year 7 students, 90 have blue eyes. Calculate the fraction of the Year 7 students with blue eyes. So remember, this is what fractions are. We're sort of dividing the year into 200 students, and we have 90 of them. Numerator is how many you have. Denominator is how many you've divided into. So 90 out of 200 students have blue eyes. This fraction is correct, but it's not simplified. Whenever you give your answer as a fraction, it should always be simplified. So I know it's not simplified because 90 and 200 both have a common factor. They're clearly both divisible by 10. So we can divide the top by 10 as long as we divide the bottom by 10. So dividing by 10, we can just cross out the zeros at the end. I'm left with 9 over 20. 9/20ths of the year group have blue eyes. This is the simplified version of the fraction. This can't be simplified any further because 9 and 20 have no factor in common other than 1. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.